Good morning, students. Welcome to the third video lecture on design and analysis of algorithm. As in the last video, we had seen about the time complexity for a simple algorithm, that is sum of n numbers. So we saw that how to calculate the time complexity by using a count method. In the next example, we will see one of the matrix addition example, wherein addition of two matrix and calculate the time complexity of this particular algorithm. In this example, we can see we have two loops I. I is going to iterate for row wise and j is going to iterate for column wise. So in this way, the addition of first row, first column of A along with second row, first column, first row, first column of B added is stored in the first row, first column of C. In the same way, all m cross n addition is done and it is saved in the C array, and the resultant matrix of addition of two arrays A and B is saved in C. Now, how to calculate uh, time complexity by using a count method? As stated in the previous example, after execution of each statement, we are going to write a count increment statement. Now, you can see for this for loop, we have added a count is equals to count plus 1. For this for loop, we have written count is equals to count plus 1. And for this addition, we have written count is equals to count plus 1. So, how are this going to execute? If you go for the first example, now how many times this first count is executed? As I said in the previous example, for any for loop, the value is, if the loop is going to iterate for n times, the time complexity is n plus 1, because plus 1 is for condition checking. Condition checking. So always for any for loop, the time complexity is n plus 1. In the above example, when this for loop is going to iterate from 1 to m, so for I, the time complexity of first for loop is m plus 1. Okay, so this statement is going to give us 1 plus 1 complexity. Second one, it is going to iterate for n times. J is going to iterate for n times, but how many times it is going to iterate from 1 to n is m times, because it is a nested for loop. For each value of I, j is going to iterate from 1 to n. For I is equals to 2, j is going to iterate from 1 to n. Till I is equals to m, j is going to iterate from 1 to n. So for all this, number of times that for loop is executed is n plus 1, but how many times? M times. Since it is a for loop, so it is going to have n plus 1, and it is going to execute for m times, so it is m into n plus 1. So this line time complexity is m into n plus 1. Next is addition. The addition of this is done for n into m times, because for each value of I and for each value of j it is executing, so it is n plus 1 times. So if you are going to calculate the total, first one is m plus 1, next one is mn plus m, next one is mn. So according to this, mn are 2, so you can write 2mn plus 2m plus 1 is the time complexity of this particular algorithm. So this is not n, this is 2m plus 2mn plus 1. This is the time how we calculate the time complexity using a count method. There is another method called as table method. So we will see how to calculate a table using a table method. It's very easy. The same concept of count is applicable. In table method, we have a table form. Suppose this is my table. For first problem, if we go for sum of n numbers, okay, so I will write that algo, sum of n numbers algorithm is algo sum a comma n. Later we have s is equals to 0.0. Then we have for I is equals to 1 to n do. Then we have s is equals to s plus a of I. Then we have written s. Here we have statement per execution. Then we have frequency of execution. Then we have total repeats. Okay. This is how we are going to calculate in terms of table method. Now, what does statement per execution means? At a particular instant of time, the number of times that statement is executed. Number of statement is executed is statement per execution. In the first case, s is equals to 0 0.0 at one instant of time, only one statement is executed, so it is 1. Frequency is how many times that statement is executed. For first statement, it is executed throughout the program only once. So this total is statement per execution into frequency. So 1 into 1 is 1. Now, for loop per execution, it is executed only once. Number of times it's executed, as I said, it is n plus 1 times. So this into this is n plus 1. So S is equal to x plus AI. Per time execution, it is executed only once, and number of times executed is n, so total is n. Return S, this is executed only once, frequency is 1, this is 1. So if you are going to do the calculate total, this is 2n plus 3. As the same we have got using, you can see, we have got 2n plus 3, same using count method and same using the table method. So this is how we can calculate simple execution complexities for simple problems based on count and table method. So when it goes for the runtime, that is the instance characteristics, when the complexity of the program goes on increasing, like if you go for the divide and conquer concept, or if you go for the greedy approach, the complexity of algorithms goes on increasing, then the solution of the problem cannot be obtained by the simple method. In that case, we have to solve it by different methods called as master method, substitution method, and so on. So now we will move to the next part, if that is asymptotic notation. This is a most important part in algorithms. These represents different range of time complexity values. Definition of asymptotic notation is asymptotic notations are mathematical tools which allows us to analyze an algorithm's running time depending or identifying its behavior on the input size group, because this is defining that it specifies what how the algorithm's running time changes with the input size growth. That is completely defined by asymptotic notation. How the size of n varies based on this size of n, how the running time increases, that is complexity increases. This is represented by asymptotic notations. So these are represented in three ways. There are three types of asymptotic notations: big O, omega, and theta notation.